We looked at the meaning of and or algebraically, and now we're going to take a look at sort of the geometric representation of those. The geometric representation of and, meaning common to both, is intersection, and or, which includes everything in either set, is union. The symbol for intersection is that upside down U, and easy to remember, the symbol for union is U. We'll look at intersection and union making use of what are called Venn diagrams. These circles that you see here and overlapping circles like that were first introduced by a man called John Venn in about 1880 when he put them in the Journal of Science to help describe logic, different logical representations of many things. They're similar to Euler diagrams that were introduced a little bit earlier. Anyway, so A intersect B, for example, in this diagram would simply be what's common to both A and B. So in this case, it would be the numbers 8, 6, and 4. And A union B would be everything in either set, which would be 1, 2, 3, 4, 5, 6, 7, and 8. Now notice I didn't list what's in A and list in B because it's pretty obvious by looking at the figure. But again, all of A would be 1, 4, 6, 7, 8. So remember, when you're saying A, it does include what's also in the intersection, the things that run into B also. And set B up there would be 2, 3, 4, 5, 6, 8. Those values. Now if we just want to represent A intersect B, and there are no numbers in the sets to designate what we want, then we just shade that region where A and B overlap. In other words, what's common to both A and B would be that red area. Representing A union B, again remember union means include everything in either set, and I want to make sure that I indicate everything in A and B, so that would look like this. So in gray underneath the figure you see the representation of intersection and union, and then if we wanted to use the numbers that we see up there, the intersection in A and B would be, so think, right, 7, 9, and the union of A and B would be 1, 3, 5, 6, 7, 8, 9, and 10. And notice in this case 2 and 4 are outside of A and B. So we treat that red rectangle that you see as the universe, is what it's called. Universe, and sometimes you'll have values that are outside of the circles but within that red rectangle. So in the universe, not in A and B, of course, would be 2 and 4. And there's some types of problems where we're going to want to fill in the numbers by maybe a description or even numbers listed in sets as we have here. So if you look at the bottom of the page, it says, all the whole numbers from 1 to 10 are to be included. So remember, the whole numbers are not fractions or decimals in between, just those integers from 1 to 10. So we're given set A and B, and I think the easiest way to do it is to first think of, well, what is A intersect B? So look at those two sets, and what's common to both of those two, and I only see 8. So 8 would go up here in the middle in the intersection. And now we want to look at set A and say, well, what are the other things in set A? And that would be, I'm not going to put them in the rectangle, so 1 and 4, 5, and 7. Again, 8 is in A, but we already have it in A by putting it in that middle section that's both in A and in B. Okay, now look at set B. Set B has that 8 that we put in the intersection, but it also has 2, 6, and 10. Now remember, we were supposed to have all the whole numbers from 1 to 10. So you just want to look up and see what wasn't included yet. So 1, 2, so 3 we're missing. So I'm going to put that in the universe outside A and B in that rectangle there where they have D. 4, 5, 6, 7, 8, but again we're missing 9, so you want to put 9 in there also, and that takes care of all the numbers. So here's a similar problem. And the universe should be all the whole numbers from 1 to 10 are to be included there. So sometimes it's easier to actually list what belongs in A and B first. So I'm going to do that in this one. Set A contains all the odd numbers in the set. So that would be 1, 3, 5, 7, and 9. Set B contains all the numbers greater than 4. Right, so 5, 6, 7, 8, 9, and 10. So let's start with the intersection. So look at those two sets, and you want to choose what's common to both. In this case, that's 5, and 7, and 9. And then we want everything in A that we haven't included yet, so you're going to take out your 5, 7, and 9, which leaves 1 and 3, which belong in the region outside of the intersection, but still in A. And then look at B, so if we take out 5, 7, and 9 that we've already used in the intersection, that leaves 6, 8, and 10. And now down here in the universe, you want to see, well, what's left? So again, remember, the universe should be all the whole numbers from 1 to 10. So we've left out, if you just start counting, 1, 2, so we've left out 2, so I'm going to put down that down at the bottom. 3, and we don't have 4, so 4 goes in there, and then we have 5, 6, 7, 8, 9, 10. So that's it. Often you have more than 2 circles that you want to deal with, and as we add more circles, it gets a little more confusing. These are sometimes missed on tests. So I'm going to go through some examples. Of course, we'll do some in class. So let's start with the red one up here, A intersect B union C. So first of all, A intersect B is what's common to both A and B, which would be this part right here. And then union C means we also want to include all of C. So I'm just going to go ahead, a little piece of that was already in C, but I'm just going to go ahead and add everything else that's in C, and that would represent A intersect B, union C. Now I'm going to go ahead and erase that, and we're going to now do in blue, A intersect B intersect C. So A intersect B is this. Again, same thing we had before. Now often when I'm going to do an intersection, I'll slant it a different way. So if we want to intersect C, here's C. Now again, remember, we're not going to want all of C. What we want now is the first thing we did that I slashed sort of with a positive slope, and then C that I slashed with a negative slope. But we want the intersection of those two. So that's the crisscross area. So it's easier when you're doing this in pencil, you're just going to maybe lightly do the two and then darken this middle part. But the only part of the solution here is this middle part. So you'd have to make sure on a test that I can read what you're giving me as your interpretation of that answer to that. So that would be the intersection of A and B intersection and C. Now if I erase that, we'll go to not C, which is a new symbol there, and that little squiggle is called a tilde, and in this case it means not C. In geometry a lot of times we'll call it the complement of C, meaning everything but C. So not C in this case, again we don't have the universe drawn, so we're just going to use our other figures, and I'm just going to shade everything that's not C. So everything in A and B except the part that overlaps C. So that would be not C there in purple. Okay, so now I'm going to erase that part. And we'll get to the last one there in brown, which is B intersect not C. Okay, so here's not C. So again, I'm going to sketch in everything that's not C. And then we want to intersect that with B. So now I'm going to do a negative slope. Here is B. Sorry, I was thinking I was doing not C. There's B. Okay, so now again you want to look at the crisscross area. So it'll get kind of messy if I start doing too much here, but you see where all the waffled pattern, that's going to be your answer. So again, you can, if you do them both lightly on a test and then just darken a little bit the crisscross area, that will be fine. But basically here's all the region that we want for that. So sometimes it's a little bit difficult to do that all in your head, so it's not a bad idea. Just take your pencil and sort of cross it one way and then cross it the other way, and then in this case, because we want intersection, we only want what's common to both, and that's that waffle pattern. Okay, here's some fun ones. Let's see if we can name some of these regions by setting up an intersection statement or a union statement. So I'll give you a little time in between, or actually why don't you just hit pause and see if you can think of them yourself. So let's start with the yellow region on that figure on the right and see if you can think of a way to name that. There's not just one way usually, but this one's pretty straightforward, so I would just say not B. Again, nothing's else drawn, and we're going to treat just that double circle there as just the only figure in that particular case. Okay, now let's go over to the figure on the left and see if you can name the green area. So for the green area here, I would say A intersect B intersect C. Again, that's for that green area there, because that's what A and B have in common with also C, so it's the intersection of all three. Now try the red one there. So for that red one, I think I'd say A intersect B, not C. Actually, I should say intersect, not C, sorry. Let me erase that. Alright, so that should be A intersect B, and then intersecting not C. So that's the red part on that figure. Okay, let's go down to that lower figure, and let's just do the part that's kind of in blue there, just this part. See if you can name just that part. So I think I'd go with just not A union B. In other words, we want everything in that figure that's not in the union of A and B. Okay, so we'll try some more of those in class too, but replay that if you'd like. Okay, see if you can do each of these. So A would be, so think, so you said 1, 2, 4, 5. B, 2, 3, 5, 6. C, 4, 5, 6, 7. Not C, so that should be 1, 2, 3, 8. Notice that number outside in the universe, because this time we do have the rectangle. And then B union not not C? What would you do for B union not C? So B is 2, 3, 5, 6, and then in addition to that we want anything that's not in C. So we're going to go ahead and add 1 and 8. Okay, and then A intersect B union not C. Well, A is 1, 2, 4, and 5. And B union not C, so we want all of B, because remember, union means you're going to include everything you're saying there. So 2, 3, 5, 6. There's all of B. But we also want in this set not C. So not C would also be, I don't have 1, and I need 8. Okay, so now we look at those two sets, and now we choose the intersection. So I wouldn't do too much in your head. I would definitely write those both down and now look and say, all right, what's common to both of those? Because that's the intersection. So again, our solution here then is we want 2 and 5, and that would be the solution. Okay, now look at the red figure there and see if you could name how you might want to say that. Again, there's more than one correct answer, but I might start with A intersect not C. So A and then the intersection of not C again, so that would be the part A and then any place where it intersects outside of C. And then I might union with that just A intersect B. Then I'll get to add that little triangular region too. So A intersect B. Again, there can be other ways to say this, so we can take a look at that in class if you want. So this is a little bit different type. It's just asking you to describe set S. So if we look up there at S, and did you come up with, that would be the perfect squares, perfect square integers, let's say, less than 20. So again, if you look at the original, it says the whole numbers from 1 to 20 are included in the Venn diagram. So I'd say that set S is the perfect square integers less than 20. How about set E? So that just looks like the even whole numbers, or integers, either one at this, you could say for this. Even whole numbers between 0 and 21, something like that. Okay. So for the last one here, number shapes below are sorted into two sets, R and Q. And set R should contain the shapes with a right angle, 90-degree angle, and those are, you can see those little corners drawn in some of the figures. And then set Q contains the shapes with 4 sides. Okay, so again, I usually find it simplest to start with the intersection. So what are the ones that not only have right angles, but also 4 sides? And that would be number 1, that one, and 4 sides and right angles would be number 5, right, that one, and that's it. So now R, we want all the shapes that contain right angles, so now I'm going to put in R, but outside of that intersection, everything else that has a right angle. So that would be 2, 4, for those right angles, and I guess that's it. Okay, and then Q should contain shapes with 4 sides. So we already have 1 and 5 in there, right? Those two are in both. But anything else with 4 sides, it looks like 6 has 4 sides, 7 has 4 sides, and that's it. So now in the rest of the universe, we have not used 3, which is a triangle, and we have not used 8, which is a hexagon, 6 sides, and we have not used 9, which is also a triangle. Okay, all right, we'll work on these more in class.